we're going to do learning target 7 today, and we'll do learning target 8 tomorrow. Learning target 7 is just more algebra and more identities. So today we're going to talk about the double angle and half angle identities. Again, more identities that you don't have to memorize. They're on the formula sheet for you to use. You just need to know how to use them, and you'll be fine. So here are the half angle identities. So we have some angle divided by 2. And you see they're all very similar, and they all have a plus or minus sign. The plus or minus will be up to you to determine based on what quadrant you're in and what function you're using. Right? So if you're in the first quadrant, everything's positive. No need to worry. If you're in the second quadrant, though, cosine is negative and tangent is negative. So you'll need to make sure that you use the appropriate symbols. Okay? Again, these are on your paper. They're on your note sheet. We're just going to use them. Now we use them very similarly to what we do with the sum and difference identities. So in learning target 5, there are problems where it said find cosine of 165, and we added 2 angles to get to that. Same idea. In this case, we have angles that are half of some angle on the unit circle. So you will need your unit circle. And we're going to use identities to find these values that way. So first example. You have sine of pi over 8. We need to change that into degrees. So you have sine of 22.5 degrees. Now before you move on, you need to realize what quadrant you're in so you know what symbol to use. 22.5 degrees, that's in quadrant 1. So everything should be positive. Sine is positive. You'll be using positive value. Now the identity of some angle divided by 2. So we need to have some angle divided by 2 that's equivalent to 22.5. 22.5 isn't on the unit circle, obviously, but we have some angle that we can divide by 2 to get 22.5. So we're always going to multiply by 2 to figure out what the angle is. So 22.5 divided by 2 is 45. So we're going to be using the 45-degree angle on the unit circle to figure out what the exact value is of sine of 22.5 degrees. So the identity says the square root of 1 minus cosine of that angle divided by 2. We have 1 minus cosine of 45 all divided by 2. Cosine of 45 is on the unit circle, so we can fill that in. Minus the square root of 2 over divided by 2. And then we just need to clean it up. We've done all the algebra. So I'm going to go ahead and multiply by the reciprocal. I have 1 minus the square root of 2 over 2 times the reciprocal, 1 over 2. And I'm just going to distribute. So 1 times a half is 1/2. And 1/2 times the square root of 2 over 2 is the square root of 2 over 4. Right? When you're multiplying fractions, just multiply straight across. Be very careful. People forget about that 4 all the time. Now I just need to find a common denominator. So 1/2 is the same thing as 2 over 4. So I can combine this. So I have 2 minus the square root of 2 over 4. And then the only thing left we can do is we can take the square root of the numerator and denominator separately. Square root of 2 minus 2, which I know is messy, over the square root of 4, which is just 2. So please notice that the square root is only in the numerator now. It's not over the entire fraction. And I know that this is still messy. We have lots of 2's. We have a square root under a square root. But that's as pretty as it's going to get. And that is the correct answer. So that is the exact value for the sine 0.5 degrees. We just used 45 to help us get there. All right, so that's kind of the premise of the half angle identities. Let's do another one. We'll do tangent of 165. So if we're thinking about this, 165 is in the second quadrant. And tangent in the second quadrant is negative because it's sine divided by cosine, and cosine is negative. So we're going to have a negative square root, okay? So, again, we need to multiply by 2 to figure out what angle we're using from the unit circle. And that's 330 degrees. So I'm going to have tangent of 330 divided by 2 equals negative, and tangent says we have 1 minus the cosine of the angle over 1 plus cosine of the angle. So 1 minus the cosine of 330 over 1 plus the cosine of 330. Just double check, yep, minus plus. And then we use our unit circle and we do some algebra. So the cosine of 330 degrees is the square root of 3 over 2. And so now I just need to go through and simplify. So in this case, we're going to have to use the conjugate. You always look at the sign in the denominator to decide what the sign will be in the conjugate. It's always opposite. Again, the whole point of the conjugate is to make sure you get rid of the radical under the denominator. So we're going to FOIL, right? 1 times 1 is 1. 1 times the negative square root of 3 over 2 is negative square root of 3 over 2. Negative square root of 3 over 2 times 1 is negative square root of 3 over 2. And the negative square root of 3 over 2 times the negative square root of 3 over 2 is positive. The square root of 3 times the square root of 3 is the square root of 9, which is 3. And 2 times 2 is 4. You can be very careful when you're FOILing. In the denominator, you have 1 times 1 is 1. Then again, the whole point of the conjugate is that you have opposite signs, so the middle terms will drop out. And then you have positive times a negative, square root of 3 over 2, so you have a 3 over 4. All right, so now we're just going to try to put all this together. 1 plus 3/4. That's 4 over 4 plus 3 over 4 is 7/4. And you have 2 square roots of 3 over 2 in the numerator. In the denominator, you have 1 minus 3/4. That's a 4th. Now, side note, these 2's will cancel out. And so now I'm going to multiply by the reciprocal in order to finish this out. I have 7/4 minus the square root of 3. That's times 4 over 1. So I need to distribute. 7/4 times 4 is 7. The 4's cancel out. And then you have 4 times the square root of 3, so that's 4 square roots of 3. That's the answer. I know, it's messy. I apologize. Now, there is a more clever way to do this problem. You don't get the same looking answer with different numbers, but the answers are equivalent in their decimal forms. So let me show you that in case you want to use that instead. I think it's shorter, uses less steps. You still have to use the identity. You still have to multiply by the reciprocal. But if you notice, when you multiply by the conjugate, the numerators are the same. So instead of FOILing, you could have the square root of 1 minus the square root of 3 over 2 squared, right? Something times itself is squared. Since we have a square root and a square, that might work out in our favor. The denominator you still would have to FOIL, and you'd have 1 minus 3/4. So I've got negative square root 1 minus the square root of 3 over 2 squared over a 4th. This is just, again, an alternate way of doing this problem. Now, since we have the square, we want to get rid of that. We can take the square root of the numerator and denominator separately. So the square root of the numerator is just 1 minus the square root of 3 over 2. And the denominator, you take the square root of a fourth. Well, square root of 1 is 1, square root of 4 is 2, so you have a half. So now you just have a fraction divided by a fraction, and we can multiply by the reciprocal. We have 1 minus the square root of 3 over 2, all times 2 over 1. And I can distribute. 2 over 1 times 2 is 2. And 2 times the square root of 3 over 2 is just the square root of 3. So we can leave it like this, or we could distribute that negative. We'd have negative 2 plus the square root of 3. Either one of these. Again, if you type that into your calculator, you'll get equivalent decimal forms. Okay? I know these are long, but you just use the identities, and you're going to have plenty of time to ask questions in class today. All right, one more type of identity. You have double angle identities. So let's say theta is some angle measure, and we want to double that angle measure. Well, then we have identities that allow us to do that because, again, not always do we know the actual angle measure. Sometimes we're just told it's theta. We don't know what angle that is. Okay? You have 3 different identities for cosine 2 theta. The one on the top is highlighted on your notes because that's what's on the red formula sheet. If I think you need the other ones, then I'll make sure you provided them on the quiz. Okay? So it says use the given information to find sine 2 theta, cosine 2 theta, and tangent 2 theta. All right? So we'll find all 3 of these. We're just going to do this first example. It says everything theta is between 0 and 90. It means everything's positive, so that's all we need that for. Everything's positive. So sine theta equals 2/5. So if I'm going to do sine 2 theta, I just need that identity, and it says 2 sine theta cosine theta. Well, if I'm going to fill this in, then I only have 2 times 2/5. I still need cosine theta. Now, you've done this enough that hopefully this is not shocking to you. But if you have sine, how are you going to find cosine? Right? We're going to use our Pythagorean identities that we've been using for a long time now. So we have 2/5 squared plus cosine squared equals 1. That's 4/25. 1 minus 4/25, that's 25/25 minus 4/25 is 21/25. And then you got to take the square root to get the square root of 21 over 5. Once I have that, I can plug it into identity and just multiply straight across. 2 times 2 is 4 times the square root of 21 is 4 square roots of 21. And 5 times 5 is 25. There's sine 2 theta. It took some work to find the missing piece, but the actual identity part wasn't that bad. So we found sine 2 theta. Now we're going to find cosine 2 theta. Again, you have 3 choices. If you just had cosine, I would, of course, use the second one. If you just had sine, I would use the third one. We have both, so I'm going to go ahead and use what's on the formula sheet. So it says cosine squared theta minus sine squared theta. Be careful, 2 and squared are not the same thing, so make sure you're using your notation correctly. So cosine is the square root of 21 over 5, and we're going to square that. Minus sine is still 2/5, and we're going to square that. And so we have 21 over 25 if you square that separately, and then 4 over 25 if you square that separately. And so 21 minus 4 is 17. So there's cosine 2 theta. All right. We found those 2. So now we're going to find tangent 2 theta. Now, tangent 2 theta says 2 tangent theta over 1 minus tangent squared theta. Now, you could do this the long way. And you have sine, and you have cosine, and you could do sine divided by cosine, and you could find tangent, and then you could plug it into the identity. That would work. But here's a shortcut since we already have sine 2 theta and cosine 2 theta. Tangent 2 theta is also sine 2 theta over cosine 2 theta. That idea still works. I have sine 2 theta. I have cosine 2 theta. I've got a fraction divided by a fraction. So I multiply by the reciprocal. So there's tangent 2 theta. Again, this would also work if you found tangent from the originals and then went through and used the identity. Both of them are the same. Okay? I won't do the second example. In this case, you're in the third quadrant, so that's tricky. You have tangent, so you could go ahead and find tangent 2 theta if you wanted to. In order to find sine 2 theta and cosine 2 theta, though, you'll have to find sine and cosine. So you're going to probably have to use one of the identities. Tangent squared theta plus 1 equals secant squared. Once you had secant, you want to find cosine. Once you had cosine, you probably want to use sine squared plus cosine squared equals 1 to find the other. So it's still going to involve some work, but once you have the individual pieces, you can use the identities to plug them in and find the actual exact value. All right, I will leave you alone, and you can work on Learning Target 7 assignment, and then we'll do Learning Target 8 tomorrow.